Well, I'm glad to see you here. Wonderful person. All right. So let's see what we got going on today. Actually, this is going to be a lesson that's going to be continuing what we covered on Thursday. So on Thursday, we were talking about factoring. Now, factoring is something that generally was covered in Algebra 1. So I did a quick factoring refresher. Well, actually, that was my longest video to that date. So I tried to make sure I covered it really good. So if you're not sure on all the steps of factoring, that you go back and probably watch that video. If not, then just try to keep up with what I have, because we're going to still keep using them. We're going to still keep using the factoring methods that I went over. But if you feel like you're okay on factoring, then let's go ahead and just move to here. So that's going to be move all terms to one side and set the equation equal to 0. So you might remember from solutions of quadratics, we call them zeros, we call them roots, and x-intercepts. So in this case, this is why we call them zeros, because that's the place that it's equal to 0. Next thing we do is we factor it. So remember, there are a couple of different kinds of factoring. There's what I call reverse distributive. There is the trinomial that I like to call the Loif formula. So that's L-O-I-F. And then the last one are difference in squares. So those are the three main ones, and those are the ones that I usually cover. There are probably a few more, but most of them can be covered by other methods. And again, I use what I call Loif method. There are other methods. If you know any other methods like AC method, X method, or anything else, then go ahead and use those. All right, now after you factor it, set each of the factors equal to 0 and solve for each X value. So it's just like kind of making two mini algebra problems, two little equations, and then you're gonna solve for each of those equations and write your answer as a solution set, which means X is equal to, whatever we have here, like 5 and 2 or something like that. And I also have a quick rundown here of my Loif method. So it's easy to remember because it's just FOIL, but backwards. And if you remember what FOIL is, it's how you multiply two binomials to make sure you get it's a way of making sure that every number multiplies by another number. So it stands for last, which means look at the last two numbers and think of two numbers that will multiply to get your last number in standard form. So in standard form, you're looking at the C value. So C value here, what are two numbers that can multiply to make it, okay? But when you're thinking about this, also consider the sign. The sign is super important and is probably the biggest thing that people forget. They'll sometimes get the right numbers, but they'll get the wrong sign. So remember, 5 and -5 are not at all the same thing. They look the same, they kind of sound the same, but they are not at all the same numbers. Having $5 and owing $5 is not at all the same thing. So make sure you pay attention to that sign. All right, now, and if the two signs on this last term is a positive, that means they are the same. Okay, it doesn't mean they're positive, it means they are the same. If it is negative, that means they are different. And if they are the same, they're going to be the same as whatever the first one is. Now, when looking at those same two numbers that you got from the first step in this part here, those same two numbers that multiply to that last number must also add to the middle number. And also keep in mind about the sign too, because the sign is going to make a difference. Okay, probably one of the bigger differences, because again, I know all the time students will get the right number, but they will get the wrong signs. And then the last thing you do is in this case here, our A value, multiply or get those two numbers and think of those two numbers that multiply to the first number. Now this method here kind of works when there is, well, it kind of works on everything, but the only time it doesn't really work is when you have an A value. So if I were to have something like a number here and to start off this expression or equation with, then I'd have to come up with another one. So that in that case, you would use AC method, which I'll also cover here. But you could also try another one, which is called solve by trial, which means you just keep trying something until it works. All right, so don't be afraid of that. I know sometimes, I don't know why, but students just seem to be afraid of getting a wrong answer. But sometimes you need to get a couple of wrong answers, because finding out, you know, something that works really involves trying 1,000 things that don't work. All right, but in this case, it's probably only going to be like 4 to 6, maybe 8 different things. Anyway, so let's go ahead and get this and solve by factoring. So let's see what we have here. So we have a binomial, so we only have 2 terms. And in this case here, well, we can't really use the Loif method. Well, I guess we could, because it would be 0, but then we'd need 2 numbers that multiply to 0 but add to 9. And if you have 2 expressions, or sorry, 2 terms in your expression, that usually means it's going to be reverse distributive. So we all know what distributive property is, right? You have a group and you're doing something to that group, usually multiplying. But in this case, we're taking away. So I have x here and x here on both terms. Now remember, I can only take away the most that I can get from any one group. So this first term has 2 x's, and we are going to take one of them. The second term has only 1 x, so when we take it, it will be left with none of them. And if you want to check it, so in this case here, I want to check it to make sure that we are getting the right numbers when we take it out. Now remember, this is not dividing, because when you divide, you're making the number smaller. In factoring, you're taking it out. You're just taking out one of these x's. So if I were to multiply x times x, I get x squared. Okay, so that works. And the second term is 9 times x, which is 9x. So that works out. So we didn't miss anything. Now, if you remember, okay, so this is the second step, which is to factor it. It's already gotten all the things moved to one side, so we don't need to worry about that. So let's move on to the third step. The third step is to set both factors equal to 0. So if it has a parenthesis, it is considered to be in a group. So probably the best way to do this is to draw a line. And I have my first factor out here. So remember, a factor is a number used in multiplication, because this is multiplying times this to make that. That's why it counts as a factor. Now I'm going to go ahead and set this side also equal to 0. Now this side has already been solved. There's nothing else we can do. So we already have our first solution, and that is x is equal to 0. Now, to solve this one here, I'm going to have to do a little bit of work. I'm going to have to minus 9 from both sides. And that gives me x is equal to -9. So I have my second solution, actually. So now I have both solutions. And the fourth step was to write this in group form. So x equals, because now normally we would say x equals something like 0 or x equals -9. But since we're talking about a solution set, we have to use the set builder notation parentheses, which are those, well, they're called braces, or was it brackets? Anyway, it's this one here. So it's that one that kind of looks like a sideways W. And I'm going to put it in numerical order, which means that I'm going to start with the lower number. So even though I found x first and it's on the left side, I'm going to put this one first just because it's lower on the number line. So if you imagine a number line, that one's going to be the farthest one to the left. So we have both our solutions and we are done with this first one. All right, so let's go ahead, and I think we're ready to move on to the second one. Oh, before I move on really quick, why these are also called 0 is because if I take -9 and I plug it in here, so I'm going to just do this once, and you're going to have to kind of take my word for it. So I'm going to plug in -9 into the original equation. And it should come out to be true. So there you go. I plug in -9. Oops, I forgot the second -9. So -9 squared is going to be +81. 9 times -9 is -81 or -81. 81 minus 81 equals 0, so this is true. So if I plug any of these numbers into the original, I should get 0 as the output, right? The result is going to be 0. That's another reason why we call them zeros. All right, which kind of makes me wonder where the word roots comes from, because I don't know how people got the word roots. Anyway, so let's go ahead and put the parentheses on these if it helps, okay? But let's just look at these two terms and think of what is the largest thing that we can take out of both of them? What are the largest factors? And a quick reminder too, again, we're not dividing, even though technically you can think of it as dividing and it will still work. So this is 4 times 1 and 4 times 2. So these are the two factors that make up 4. And well, I chose 4 because they both have 4. So if I take out 4, well, I'm also gonna have to take out an x as well because one has 2 x's and the other has 1 x. So if I take that out, I'm taking 4x from this first term. So his 4 is gone. That leaves him with only 1. And there's 1x left over, so that's why we have that first term as x. Now the same thing is with this one here, so we're going to take away the 4, because we took it out and we're putting it outside now. Now again, you have to have this outside number. We're not dividing. I know a lot of students, they think it's dividing, and usually when you divide something, you get a smaller number, but we're not trying to make the number smaller, we're trying to move pieces around. And in this case here, the x would also be gone too, because there was an x, but now it's gone. There you go. So now we've taken it out. And again, if you want to check it, you can test it by distributing both of them to get the original back. So maybe that second one is a little bit weird. So 4 times 2 is 8. That's true. And then x times 8 would be 8x. So it works out. Now let's go ahead and take both of our factors. So the first one is 4x. So again, this is being multiplied. Sometimes I have students put parentheses on there, even though normally that's not what it looks like. But if it helps, go ahead and use it. And in this case here, I'm going to go ahead and put x minus 2 equals 0, the second factor, also equal to 0. Now I'm going to solve both of these. So to solve them, I'm just going to go ahead and use my normal, ordinary, everyday powers of algebra and just work it backwards. Work it backwards using the inverse property. So divide both sides by 4, I get x equals, well, 0 divided by 4. So 0 divided by 4 is going to be 0. And here I have x minus 2 equals 0. So what number can I minus 2 from to get 0? Well, if I had 2, that would work out. We're going to add 2 to both sides. And now check to see which one is the less number, the lesser number, and the greater number. So put them in order. So in this case, I'm going to say x equals 0 and 2. And don't forget those wavy parentheses. And in this case, I'm going to go ahead and box them. I think sometimes I don't do that, sometimes I do. In this case here, I feel like maybe I could skip it just because those wavy parentheses would make me think, well, okay, that makes it stand out as the answer. But in this case, it's not a big deal to just box it. So I'm going to go ahead and move on from this one here. So let's go on to the next one. So there's actually going to be quite a few to do. All right, so another one that has 2 terms. So you might be looking at this and think, okay, well, let's try reverse distributive. Now let's see if we can take x away from both of them. So no, we cannot remove a factor of x from both of them because, well, this one has 2x and this one has none. So if it has none, you can't remove any from it because it's like asking someone who has no money to pay for something. So how could we factor this out? All right, so from the last lesson, again, there was difference in squares. How you recognize a difference in squares, I don't know if I could write this down. I think I wrote it down before, but I ended up having to change the lesson, so I can't get back into it from here. So how you recognize a difference in squares? Well, first off, there has to be a difference, and difference means subtract. So there's a subtraction going on, but both terms have to have square numbers only. So x squared is a square number, and 4 is also a square number. So remember, a square number is any number that you can multiply by itself to get that number. So like square numbers would be 1, 4, 9, 16, 25, 36, 49, 64, and so on. All right, so now that we know this is a difference in squares, we're going to go ahead and set up our parentheses. And you could also use the Loif formula if you remember that we need two numbers that will multiply to -4. So what are two numbers that will multiply to -4? Well, you might say 2 times 2, but 2 times 2 would be +4, not -4. Now, the thing that kind of makes this tough is that this one is lacking a b value. There is no b value in this case. So the only way to get a -4 is if one is positive and the other is negative. And then you need the last number. The last step is the first number. So two numbers that multiply to get us x squared. And there you go. And if we want to check on this, we can. X times x is x squared. That's true. And I'm using the FOIL formula. So FOIL is first numbers, outside numbers. So that's -2x. Inside numbers plus 2x. So 2x minus 2x, it's nothing. It's gone. That's why there's nothing up here. Okay, that's why our b value is gone. It's zeroed out. And 2 times -2 is -4. So there we go. We got it. And again, I'm going to kind of show you on the next one the more of the shortcut. Once you know it's a difference in squares, it's going to be a little bit easier. So the next thing we have to do is set it equal to 0, and then set each factor equal to 0. So I have my x plus 2 here, and set that one equal to 0. And over here I have the x minus 2, which is also set to 0. Now that I have both of these set to 0, I'm just going to solve each one. So remember, to solve it, we got to do the opposite. So if it says if it says plus 2, we got to do the opposite and subtract 2 from both sides. So our first answer would be -2. And over here, our second answer would be +2, because we added 2 to both sides. Now, if I plug 2 and -2 into my original equation, it should come out to be 0. And we are largely done with this one. So let's go ahead and put our bracket up and start with the lower number, which in this case is -2, and the higher number, which is +2. There we go. And we are done with that one. All right, next one is number 4. And again, there's only 2 terms, and 9 and 25 both do not have any factors in common. I cannot divide 25 by 3, and I cannot divide 9 by 5. So this leaves me with only one option, and that is to check to see if it is a difference in squares. Sorry, I almost said something a little bit different. Anyway, so 9 is a square number, x is a square number, and 25 is a square number. So all 3 of the numbers in both terms are all square numbers. And again, it's called a difference in squares because difference means subtraction. So 2 square numbers are being subtracted. Now, I did the kind of the Loif method on this one here, but I'm going to do the shortcut on this one. The shortcut is you just take the square root of both sides. So 1 positive and 1 negative. Now, both bubbles should match. They should have exactly matching things in both of them, except one is a plus and the other is a minus of the 2 terms. So 3x, because right, 9, take the square root of it, it's 3. Take x squared, the root is just going to be x. And then the square root of 25 is going to be 5. There you go. Now, if you want to multiply it back out, like here, I'd have -15x. Here, I'd have plus 15x. That would be 0, and that's why there is no b value. And that's the shortcut. Now, we still have to set these equal to 0. 3x plus 5 equals 0. And 3x minus 5 equals 0. Now this one's going to require a few extra steps, so I'm going to have to minus 5 from both sides here. And while I'm at it, these two equations are very similar, so I'm just going to go ahead and do both at the same time. And since this one is a minus 5, I'm going to have to add 5 to both sides to get rid of that. So 3x equals negative 5. 3x equals positive 5. Now in this case here, it looks like we're going to end up with a fraction, so I'm going to have to continue getting this x by itself. So all other numbers need to get away from the variable. Divide by 3, and that'll cancel that 3 out. X equals, and I think I'm ready for the solution in this case. And I cannot divide or simplify this, so I'm going to go ahead and just leave it like this. If you want to turn it into a mixed number, you know, that's okay, you can do that. You would get something like 1 2/3. But in this case, I'm going to go ahead and just leave it as a fraction. Don't need mixed numbers today. Okay, so there we go. So we got both of these. Nice and solved. Now again, this one is going to be a little bit harder to check, but if I were to take 5/3 and negative 5/3 and plug them in for x, it should come out to 0. So that's how you check it. Anyway, I'm going to go ahead and keep things moving along. All right, so here we have some trinomials. So that means 3 terms, so it looks more like our standard form. And again, I like to use this method. So in order to use this method, so first thing we got to do is check for an a value. So if there's no a value, that's great. Ready to just go ahead and get started on it. And you probably don't have to follow this order exactly, but I like to tell students to get the last term. So focus on this last number first. So in this case, we're looking at the number 21. So as we move forward, think of 2 numbers that you can multiply to get 21, but if you add them or combine them, you get negative 10. Probably the quickest number that students will come up with is 3 and 7, which is probably what it is going to be, 3 and 7. Now remember, I told you the signs are an important part of this. So a lot of times students will just look at this and be like, ooh, it's a plus, so that means both of these are plus. No, that is not how it goes. Remember what I said, they will be the same if it is a positive. Quick review, I guess. A positive times a positive is a positive. A negative times a negative is also positive. Like if I had negative 5 times negative 2, it would be positive 10. The only way to get a negative number is if I had 1 positive and 1 negative. Now it could be the first or the second one, doesn't really matter, but just remember that it's 1 positive, 1 negative will make a negative number. But since in this case this is positive, because remember these 2 numbers must multiply to 21, that means it could also be negative 3 and negative 7. And if I combine them, negative 7 and negative 3 will make negative 10. So this does work out. So there we go, we got it. And usually if there's no a value, you can just go ahead and throw in your whatever you have here, and that's it. So let's go ahead and set it equal to 0. So this is x minus 3 equals 0. And then for this factor here, I have x minus 7 is also equal to 0. So what number can I subtract 3 from to get 0? Well, let's go ahead and just add 3 to both sides. So our first solution is x equals 3. And to do the second one, we're going to use our inverse property. So if it says to subtract, we're going to add to both sides. X equals positive 7, or just 7 in general. Okay, now these numbers are already in numerical order. 3 is lower than 7, so we're going to put 3 first. 3 and then 7. There we go. So not too bad. Okay. And these are the ones that I'm always a bit worried about. So first thing we should look at is, well, if it's a trinomial, after that, the next thing we should look at is, well, is there an a value? Which in this case there, yes, it is an a value. And in this case here, there are two other things that you should also think about being able to do. So if there is an a value, other than 1, so if it's like in this case here, this does have an a value, it's just 1. So there's two things you can do if there is an a value. The first thing we could try is factor it out. And the second thing we could try is just work with it. And I'm going to write that down because I know if I don't write it down, I know people are not going to write it down, and therefore it's not going to be remembered. So factoring it out is probably the easiest way, because if I look at all three of these terms here, 2, 2, 24, I can divide them all by 2. So that's what I'm going to do. I'm going to factor all of them by 2. So these first two terms had a 2, but now they lost it. It was taken out. It was removed and put in the front. And then this one here is also going to have to be divided by 2. Now for here, for now, we're going to just ignore this. Okay, we're just going to ignore this 2. So let's focus on this trinomial here. So it looks like it's in standard form, so we're probably ready to go ahead and factor it out. So I'm going to start with drawing 2 parentheses. Now I need 2 numbers that will multiply to negative 12. But if, now here's the tricky thing. This is why I say it's important to look at the sign first. So as I look at the last term, the last term's sign, I notice that it's a negative. This means that one has to be positive and the other will have to be negative. So positive and negative. Now sometimes it's, I always tell students to focus on the sign first, because you know, if you focus on something first, you're less likely to forget it. So this means that we're not adding them together, or it means that we're going to take one and subtract the other. So if I take one number and subtract that number that multiplies to 12, how can I get it to equal negative 1 after subtracting it? So you could try 6 and 1. All right, but you can probably already tell this is not going to work, because 6 minus 1 is going to be, well, negative 5 and not negative 1, so that's not going to work out. Probably the other number that you would try is 4 and 3. Now be careful, because we're not done yet. Now 4 times negative 3 is negative 12. But in a case like this, you might also have one that doesn't work. So in this case, it doesn't work because 4 minus 3 is positive 1, not negative 1. So if that happens, you know, right number, wrong sign, just switch the signs or switch the numbers. So now negative is on the 4 and positive is on the 3. 3 minus 4 is negative 1. So yep, negative 1, we got that, and 3 times negative 4 is negative 12. So sometimes you will have to try a couple of times before you get it, all right? And again, don't be afraid to try a couple of things. I don't know why students always seem to think that you can just get the right answer, you know, without trying, without really making any mistakes. All right, so now we set it equal to 0. Now this 2 is still important, okay? Well, normally it's important because if you're factoring it, it has to be included, which in this case, there is no variable. So I get 2 equals 0, which is false. So we're just going to ignore that. Set our first factor equal to 0, and then our second factor equal to 0. There you go. So second factor, first factor, and let's go ahead and minus 3 from this one here. So minus 3, x equals -3. So we got our first solution. And second solution, we're gonna have to add 4 to both sides. So this is gonna be x equals 4. And it looks like we're done. We just need to put it into the right way of answering it out. Right way of writing the answer. Blah. Okay. So x is equal to both -3 and +4. And again, this means that it's a set. So there's 2 answers. And with all of these, there are going to be 2 answers. And kind of a quick way of explaining this, I used to tell students this, and it's still true, but if you have 2 x's or x squared, that means there are 2 solutions. Now, just kind of on an off-topic subject, if I were to have something like with a power of 3 on the x, so in other words, 3x values, there would be 3 possible answers. And seeing the way things are going with this school year, I don't know if we're going to be doing polynomials, but if we do, because there's still about 4 weeks left, sometimes you'll just have to deal with polynomials like that. Okay, polynomials, you can always tell how many solutions there are by your highest power of x. Anyway, so let's go ahead and move on. That's just a small bit of information. Just thought you'd know. All right, so with this one here, we got 3x squared minus 13x minus 30. So we have an we have an a value. So if you have an a value, we can try to factor it out, which in this case here, 3, 13, and 30, would they all be divisible by 3? No, because 13 cannot be divided by 3. 13 is a prime number. Therefore, it does not have any other factors. So we're just going to have to work with it. So how do we just work with it? Now, again, we're going to take the a and times it by c. So this is a tough one. Maybe for the next one, we could just solve by trial. In fact, this one's probably a good one to solve by trial, meaning that you can get the right answer really quickly. It looks like it. I don't know. Sometimes you just get the feeling of when you've been working with these for so long, you just sort of get the feeling like what. Anyway, so I'm going to go ahead and use this. So let's take our a times our c value, and we're going to rewrite it. So take away the a, and this, you can think of it like borrowing, right? If you don't have money and you need to pay a bill, otherwise you're going to get a penalty, you could probably ask a family member to borrow some money. And that's what this a is going to do over here. So it's going to give this 3 over to the 30, and we multiply it because it's called AC formula because you're multiplying the a times the c. So you get -90. Now, see how we have no more a value? Well, that's good, all right? Well, we still have it. It just moved over here. And if you remember, when you factor it, it's going to kind of come back. So it's not free. It's not given. It's borrowed, because borrowed means you have to give it back. Now let's go ahead and look at our sign, which in this case is a negative. Remember, the only way to get a negative is to multiply one positive and one negative number together. Now I need 2 numbers that will multiply to 90, but I'm gonna have to subtract one of them to get to 13. Now in this case here, I'm gonna go ahead and do something else. Now you don't need to do this if you wanna just keep guessing, okay? Because there's a lot of numbers that you can multiply to get 90. It's a pretty big number. You know, you could just keep trying things like 9 and 10, and then see if 9 minus 10 is gonna be -1, so it's not 9 and 10. So one thing you can do is make a factor, not a factor tree, it's a factor list. Yeah, it's called a factor list. That's what it's called. Sorry, okay. So think of the number. Start with the lowest number you can multiply to get 90. 1 times 90. And then 2. 2 times what can give me 90? 45. 3 times 30. 4 is not going to work. Now, to test it, you could also just use a calculator. Take 90 divided by 4, which 90 does not divide by 4, so that's not going to work. So let's try 5. 5 times what gives me 90? In this case, it would be 18. Now, you're also looking for a set of numbers that if you take one of the numbers and subtract the other, you get 13, or negative 13 in this case. Now, we got what we're looking for, even though we still have one more set of factors. I think this is what we're looking for because it has a difference of 13. So 5 and 18 are going to be these numbers here. Now, I did this wrong, so don't write it down just yet. Because again, you should check it. 18 times negative 5 is negative 90. But 18 minus 5 is positive 13, not negative 13. So we got the right number, but we got the wrong sign. If that happens, just change this part. So again, that is a common thing that happens. Students will oftentimes just pick the first numbers that they think will fit and not really check it. And then they'll, get the right numbers, but the signs will be wrong. So you got to make sure you check those signs. Now 5 minus 18 is negative 13, so this is right. And 5 times negative 18 is negative 90. Now remember, we loaned out the 3. So since we borrowed it, we have to give it back. So we multiplied by 3. Now we have to collect on it, and that means we have to divide by 3. So whatever number you get in here, you divide that by 3. Now I'm going to go, normally we would write our factors and do a little bit more work with something like this, especially if there's a fraction. But in this case here, we don't need to worry about that. So x plus 5 over 3 equals 0. So we're setting both of these factors equal to 0. There you go. They're both equal to 0 now. And we have to do the opposite. So we're going to have to minus 5/3 here. And then for this one, we're going to have to add 18 to both sides. So x equals, and we're going to start with our lower value number first. So that would be negative 5/3, and our higher one will be 18. Oh, I'm sorry. Oops. Because in this case, I forgot to divide it by 3. So we forgot to divide it by 3. Almost forgot to do, well, I did forget to do that. 18 divided by 3 would be 6. So actually, we're not trying to get rid of 6. We're trying to get rid of, I'm sorry, we're not, okay, I need to slow down a bit. We're not trying to get rid of 18. We're trying to get rid of 6. So you got to make sure to divide both of them by 3. All right, so x equals 6. I thought 18 was kind of a high number, so I had to quickly look over it and see if it would work, which it didn't. But now it does. So I think we are done with this one. So that's an example of using the AC method. And it works pretty well with just about anything. Just take this number, our A value, and multiply it times the C value, but then divide that same number out once you get it factored. Okay, so let's go ahead and move on over to this one here. And in this case here, I'm going to try to use Loif method, but I'm going to also be using solve by trial. I kind of don't want to do it because it takes a while. And you know what? I think it'd be better if I just keep teaching AC method. The problem with AC method is that you probably, well, just in my experience, most students do not remember it very long. So once this lesson's over, usually it's gone. But solve by trial is something that always will be useful. You know, if you are trying to take a college entrance exam next year, and you're thinking to yourself, man, how was it I factor something like this? You know, sticking with something you already know is going to be much easier to remember, but it's going to take a lot longer. So every time I have to come to this lesson, in fact, there's a lot of lessons I have to make choices on. I'm going to go ahead and just use AC method because as it is now, I don't have a whole lot of time to be working with people directly a lot. So rather than, I'm going to just try to keep things simple as I can. All right, so now we're going to have to give, or well, loan, right? So this 4 is borrowing the 6, so now we get 24. And that has the good effect of now we have no more A value. Once we have no more A value, this thing to factor is going to be much easier. So start off with the last number, which in this case is negative 24. Now, again, if it's a negative, the only way to get a negative by multiplying is if one is positive and the other is negative. That is the only way to get a negative number. Because if they're both negative, you will still get a positive. Sorry. I don't usually answer my phone during this thing here, but I'm getting some kind of warning. Okay, I'll have to look at it later. All right, so anyway, back to here. I need two numbers that multiply to 24. Now, if I take one and subtract the other, I will get 5. So again, we can make another factor list. So let's put a list here and start with the lowest one, 1 times 12. 1 times 24, which in this case, we can get 23 or negative 23. 2 and 12, which we can get 10 or positive or negative 10. We can get 3 and 8, which I can get 3 minus 8 is negative 5, or I can get 8 minus 3, which is positive 5, which actually sounds like what we want. So now that we have the one we're looking for, let's go ahead and put it into here. But again, we want to know which one it was, right? Because in this one here, we ended up switching them. So how can you tell which one it's going to be? Well, look at the sign, and that one's going to be your larger number, your greater number. So 8 is greater than 3, so I'm going to put it on the plus side. 8 minus 3 is positive 5. Okay, that makes sense. 8 times negative 3 is negative 24. That also makes sense. So okay, sorry, I just got a warning from my bank that says something like fraudulent accounts, which makes me think I might be getting hacked right now. But it doesn't look like it. It might be a scam. You got to be careful though with some of these phone thingies. It's really easy to, get scared and be like, oh no, I better do something. Oh, wait a minute. You know what? I almost forgot something again. Sorry, I'm getting distracted here. So we gave, right? We loaned it out. So we need to borrow. We need to get it back. So in this case, I get fractions. So I got fractions now. I'm going to reduce this fraction. So reduce by dividing both of them by 3. And in this case here, I can divide both of them by 3. Wait, divide this one by 2, divide this one by 3. Okay, and then I'm going to go ahead and just wrap this one up. So I have negative number here. So x equals negative 4 over 3 and x equals positive 1 over 2. And I did that just so I know which one's the lower number. So in this case, it's 4/3 and 1 over 2. Yeah, so a lot of times those scammers will try to make you scared, and you'll be like, oh no, I'm getting hacked. And then you're going to go click on their link. And when you click on their link, you're not going to the website. So in my case, it's not going to the bank. It's probably going to some website that looks like my bank. So when I enter my personal information, they get it. So they'll have my possibly username, password, and they'll be able to get into my bank and send money to some other account that I never knew existed. So yeah, be careful with that. I mean, anytime you get a message like that, don't just automatically start clicking links, because that's what they want. And usually there's some kind of element of fear. I know one student I had a couple years ago, he freaked out because like the message was something like, we're gonna send a warrant out for your arrest if you don't respond to this, or something like that. And he got all freaked out and he started like running around the room and, you know, doing that thing where with their face where they go like, oh man, what happened? And I had to, you know, I had him play the message and I'm like, dude, I got that exact same message. And like, luckily I saved that voice message on my phone, and that was able to convince him it's like, it's not you they're after. It's just like, whatever. Anyway, let's go ahead and get back to here. So one of the first things you should do is set it equal to 0, which this is not set to 0, right? We have 2x squared equals 5x. So this is not equal to 0. So that's the first thing we got to do. So to set it equal to 0, I'm going to have to move everything to one side. Now, we also have to make sure that we keep the number with x squared positive, right? X squared has to stay positive. So 2x squared minus 5x equals 0. So sometimes I can understand that some students might want to, they might want to, like in this case here, I can already see that this is going to happen right here. They're going to want to minus the x squared. So anytime you factor, you are going to need to make sure that your x squared is positive, just because, well, when you're factoring it, it's really, really tough to try to get it to work without the first term being positive. Anyway, so in this case, our x squared positive is already, our x squared value is already positive. Okay, so let's see, how can we solve this one here? So we're going to have to, well, okay, it's not a difference in squares because 2 is not a square number, 5 is not a square number. So I'm going to put a parenthesis on it, and I'm going to take out some numbers, which in this case, it looks like the only thing I can take out is 1x. And then from here, it looks like there are no other numbers that I can take out of the parenthesis. So since there are no other numbers I can take out, this is probably the factored form of our number. So let's go ahead and I'm going to go ahead and set them both equal to 0. So x squared equals 0. 2x minus 5 equals 0. Now I'm going to go ahead and solve both of these. Well, actually, I only need to solve one because well, that one's already, well, we already know it's going to be 0. So 2x equals, add 5 to both sides, and we get 5 over, well, I'm going to have to divide both sides by 2 because I still got to get this 2 out of here. So x equals 0 because 0 is the lower of the two numbers. And the higher is 5 over 2, which 5 divided by 2. And again, you can leave it as a fraction. You could leave it as 5 over 2. But in this case, I can easily divide it and get 2.5. So if you don't know how to get mixed numbers, go ahead and just leave it as 5 over 2. But basically, you're just asking yourself, how many times can 2 go into 5? Well, 2 times. That's your whole number. How much is left over? Well, if I subtract 4 from 5, I have 1 left over. That's my top number. Bottom number stays the same. Or again, in this case here, you can just imagine, like if you had, you know, $5 and you had to split it 2 ways, how much would each way be, right? In this case, it'd be about $2.50 each. Anyway, so there we go. There's the first one. Let's go ahead and do this one now. This is one of the other ones I was talking about when I was trying to use my bad example. Sometimes people might say, okay, well, why don't I just minus x squared? Well, the problem with that is you're going to have a negative x squared on this side, and that's going to make factoring it very difficult. So rather than that, I am going to minus these items. And again, I'm just trying to move everything to one side. So now I have a new equation. X squared minus 7x. Wait a minute. So looking at the terms, I have two x squared numbers. So actually in this case, this would actually be, let's see, x squared minus 7x. So that would be, okay. Maybe that's not the best idea. I didn't even check it. I thought I didn't really check it at first. I just looked at this and thought there was going to be an A, a B, and a C. So I think in this case here, since I just now noticed that they're both x squared numbers, it would probably be best to move it over there. That way I get 6x squared. And this is going to cancel out entirely, so that's just going to be 0. All right, from here, it looks like we're going to have to do this again. We're going to have to take some numbers out. So 6 and 8, largest factor that comes out of both of them is going to be 2. X squared and x means that they're both going to have an x taken out. Now we just see what's left. So 6 divided by 2 is going to be 3. X squared, but we lose 1x, it's going to be just x. And then here I have 8x divided by 2x, so 8 divided by 2 is 4, and watch the sign. There was an x, but it was taken out, so it goes out front like that. All right, now we set each of these. Now this one does have an x, so if it has an x, we're going to have to set it to 0. All right, now we're going to have to start solving it. And again, this is just some basic math stuff, nothing to worry about. 0 divided by 2 is going to be 0. And then over here, I'm kind of running out of space. So I'm going to have to minus 4 from both sides. And then I get 3x equals negative 4, and then divide both sides by 3. So in this case here, I have x is equal to negative 4/3. And again, this is just some basic algebra stuff. So x equals negative 4/3. And that would be 0. So there we go. Again, put them in numerical order, so least to greatest. And that's it. And how much time do I have left? Ooh, not a whole lot of time. And I know I'm kind of, I don't know, taking a while, but I know I'm also moving really fast. And just in my experience, this is one of those lessons that I get a lot of students that are kind of like, oh, I don't get it. And, you know, because they didn't get factoring back in Algebra 1 or whatever, or maybe Algebra 1 has been so long ago, they don't even remember that. So this is usually one of the lessons I kind of have to be very, you know, I have to explain almost everything, because I will get a high number of students starting from 0, usually. So I don't know how this year is going to be any different. And it's so tough when I can't see people's faces and seeing how much they would actually know about anything. All right, so let's go ahead and keep going. Usually I can kind of gauge what level of understanding somebody has, but that's just not a luxury I have this year. All right, so now again, I have to look at the x squared because I have to figure out which side to move it to. So I'm going to move it to that side, and that's going to have the effect of keeping it positive. So x squared has to stay positive. Not really necessary, but it really, really does help. Otherwise, you'd have to factor out a negative. But again, it's just easier to just keep it positive. Anyway, so 2 minus 1, that would just be, well, x squared minus, in this case, I have negative 50 plus 1, or 1 minus 50. Now it'd be negative 49. All right, so to factor this one, we'll set it equal to 0. We are going to have to, because this cancels, that cancels, that's why it's 0. We do have a difference in squares. Even though this is a 1, 1 is actually a square number because 1 is the result of 1 times 1. And 49 is also a square number. And there is a difference going on, meaning a subtraction. So this is going to be a difference in squares. So 1 is going to be a plus, the other is going to be a minus. 49 is 7 times 7. But again, you have to make it negative 7 because well, the only way to get a negative is 7 times negative 7 is negative 49. And if I were to take 7 and minus 7, that would be 0, which is why there is no b value here. And first number, x times x would be x squared, so I'm going to just drop x in here. And this one's actually going to be a pretty easy one. I could probably even just skip to the end from here, because I would know the only thing I'd have to do is just do the opposite. And since it's already the same number, it would be a lot easier to just go ahead and skip that. But anyway, I have negative 7, so my first answer is negative 7, and the second one will be 0 plus 7, which is positive 7. And there we go. So now we have both of them, negative and positive 7. And if I drop these into my original, I'm going to get a 0 back out of it. So yeah. Okay, let's go ahead and move on to the next one. I'm thinking this one's going to be kind of the same thing just because that's what the pattern has been like. Okay. Now let's see, what could I do? I could minus 3x squared from both sides, but then this side would be negative 4x squared, which I don't want a negative number. So that means I'm going to have to add x squared to both sides. And this also means I'm going to have to minus 81 from both sides. So that's going to make this whole side equal to 0. So 3x plus 1, 3x squared plus 1x squared is going to be 4x squared. And again, I minus 81 from both sides, which is going to cancel it from this side, so there's nothing left on the right side. Now it looks again that we have come out with another difference in squares. So 4 is a square number, 81 is a square number. A difference means that they're being subtracted, so I can go ahead and set this up. And again, I'm going to go ahead and use the shortcut, put a plus and a minus in there, and then just take the square root of both numbers and split it. So taking the square of 4, that would be 2. Take the square root of 81, that would be 9. Don't forget your x value here. Set it equal to 0. Now, let's see, 2x plus 9 equals 0. 2x minus 9 equals 0. Oh boy. So again, it's just using some basic algebra. I'm going to have to get rid of these 9s by doing the opposite or inverse operation from both of them. Okay. Now, once I cancel the 2, x equals negative 9/2, and it looks like positive 9/2. So, well, it looks like it still works out. Still get the right number and all that stuff. A little bit of extra work. These ones weren't so bad. At least we had a shortcut to work with them on. Even then, they weren't really all that tough of an example anyway. So how much more do we have? Looks like we have 3 more to go, and I'm not really sure how these are going to go. I started a bit late today, so I'm running out of time in third hour. I think I'm going to just keep going until I'm done with the whole thing, even if it goes into fourth hour, because I don't have a fourth hour. And if I remember correctly, you don't either. So we only have two more after this. Let's just keep things moving. All right, so we still have to move everything to one side. So in this case here, this means I'm going to have to minus 80 because we want nothing on this side. We want it to be 0. X squared plus 2x minus 80, and should again be equal to 0 because we don't want anything on that side. From here, we're ready to start our factoring using the Loyth method. Now I need two numbers that multiply to 80. But again, I like to start off with the sign first because in this case, the sign is negative. The only way to get a negative is if you have a positive and a negative number times together. Because remember, positive times positive equals positive. Negative times positive, well, negative times negative equals positive. And positive times negative is the only way to get a negative. So this immediately narrows it down so we don't have so many guesses to make. So we know one of these numbers is now going to have to subtract the other for the middle term. So I need two numbers with a difference of 2. Now if I ask students just, okay, think of two numbers that multiply to 80. The first one they're going to go with is 8 and 10, which actually it looks like it's going to work. So we have 8 and 10. So which one goes where? Again, look at your first term, your first operation, I should say, or the second term. In this case, it's a positive 2, which means that's going to have to be the bigger factor, the bigger number, because 10 minus 8 is 2, and 10 times negative 8 is negative 80. Because remember, again, positive times negative is negative. And I'm pretty sure we got that right. Still set it equal to 0, so x plus 10 equals 0, and x minus 8 equals 0. So minus 10 from both sides, add 8 to both sides. X equals negative 10 and x equals positive 8. So now we just got to put this in the right format. So negative 10 is the lower of the two, positive 8 is the greater of the two. So we're going to put them in that order. All right, so not too bad. Okay. If you're pretty good at factoring, like what we just did right here, it's going to go by really quick. Because again, in this case, it was a pretty easy one to think of two numbers that multiply to 80, subtract one from the other, you get 2 of those same two numbers. So let's go ahead and move on to number 14. And let's see, I think, well, okay, we have our x squared here, and it looks like we have no other x squared, so this is a pretty easy decision on where to move these. So make sure we do the same thing to both sides, and we're gonna have to look at our new equation. So x squared plus 10x, and 29 minus 4, gonna be 25, positive 25, yep, check your signs. Now I need two numbers. So let's look at the sign. Two numbers that multiply to 25. And I know the first thing that's going to come to your mind is 5 times 5, because they also have to add up to 10. Now remember, this means they're going to be the same. And if they are the same, they will be the same as whatever the first one is, which in this case, the first one is plus. So that means plus plus. So 5 plus 5 is positive 10. 5 times 5 is positive 25. Now this is another interesting case because we have two identical factors. So what's going to happen with this one here? Okay, well, in this case here, we probably won't need to do both of them because if you think about it, if we were to do it twice, we would end up with the same thing. So in this case, this is one of those cases where you end up with one solution. So you got to think back like 2 lessons or so ago. All right. Remember, there were 3 cases. The first case was, a parabola can go and create 2 solutions, 2 x-intercepts. And then there were some other ones. The other one that we talked about was a parabola that comes down, contacts the x-axis, and then returns. This is a one solution. There is also one where there is no solution, where it does not contact or cross the x-axis. Now, just to double check this one here, I'm also going to show you kind of to tie back to that same lesson again. I'm going to punch this one into the Desmos. So I'm going to go ahead and just drop on by to Desmos here, and we'll see what we get. So let's see, it was x square, and the square button again is here. X square plus, now I want the new equation that we got. Right, I want the new one, not the original. Well, I guess you could use the original as well. The whole one with two terms on both sides or whatever. Well, just to keep things simple, I'm going to use the new one that we got, which in this case was x squared plus 10x plus 25 equals 0. And in this case, I don't really need the equals 0. Actually, if I put the equals 0 in there, I only get one line. But if I take it off, you can see there's a parabola, and it's only contacting that line one time. And just to tie it back again, in that same page, if you have your packet open to that same one, I'm going to go ahead and type the next one, the number. So that was number 14. So I'm going to type in number 13. And I'm going to punch in the original just to see how that goes. Now, again, we do have the answers to those ones were +8 and -10, which we can see that this blue line is going through both of them. Now I'm gonna minus 80 from both sides and set it equal to 0. And when I do that, it turns it into a parabola. It's a very long, low down parabola, but it still crosses at -10 and 8. So again, that's what's going on. Remember, these solutions are where the parabola equals 0, or where it contacts the x-axis. So that's why we have -10 and 8 on this one, and only one solution on this one here. Now you still have to solve by factoring, okay? Because I know sometimes when I show students this, their thought is, well, can't I just use Desmos on all of them? Maybe, but the directions in this case, solve each equation by factoring, means you have to use factoring. So if you just put the solutions with no way of, I don't know how you got these, and there are other ways to kind of cheat your way through this. So that kind of defeats the purpose of learning these things, right? Because that's the whole point of this, is to learn these things, not learn how to copy something mindlessly from a computer that it gave you, because this is not Facebook. We don't tell you what to think, we teach you how to think. All right, so like I said, I'm just gonna go ahead and continue. And I'm gonna go through this one a little bit faster just because. So I have to minus x squared and add x to both sides. Okay, now let's go ahead and get both of these. And let's see. Okay, so looking at our sign here, because I need two numbers that will multiply to -65. This means that they are going to have one positive and one negative. Now 65 is kind of a tough number to work with. So I can make a factor list of this one here. So 1 times 65, nope, not that one. Can't be divided by 2. Can't be divided by 3, which in this case it looks like it's going to have to be 5 and 13. So 5 times, and that one does look like it's going to work because 13 minus 5 is 8. Now, pay attention to how I said that. 13 minus 5 is 8. Positive 8, not negative 8. So this means this is the right number, but the wrong sign. So we're going to have to kind of figure out which sign to put it in. Now, again, the larger or the greater one is the sign of this second term. So 5 minus 13 is -8. That's true. And I'm going to just check it really quick, make sure it works out. 5 minus 13, 5 times -13. Okay, that works out. Set each factor set equal to 0. And I'm going to have to minus 5 on both sides here, but I'm going to have to add 13 on both sides here. So that's going to be x equals -5 and 13. I think in this case, I'm ready to just put the answer in. So -5 and 13. Otherwise, I'd have to make a whole new line on everything. That one was a fairly easy one. Well, I mean, could have been way more tough. All right, so let's go ahead and do the next one, number 16. So first off, let's look at our x square. I only have one x square number, so that's gonna make it pretty easy. These are gonna have to go. So this is -2. Now be careful, because in this case, the order is backwards on this one here. So when I -2, make sure you keep it regular numbers to regular numbers and x numbers to x numbers. So it's going to try to confuse you sometimes into putting them in the wrong place. All right, so 44 plus, and in this case, 98 minus 2 would be 96. Okay, this one here we have an a value with. So a value means that we're going to have to, well, we're going to have to try those two things. So in this case, I'm thinking we can divide everything by 4. So let's see if we can take 4 out of everything. All right, obviously, you take this 4 out of the first one, you're only going to be left with x squared. And 44 divided by 4 is going to be 11x. And then 96, this should be 24, because I know 4 times 25 is 100. Minus 4, you just take one number off of 25, and that becomes 24. Okay, that was actually kind of easy. Let's go ahead and break this down into 2 parts and set them equal to 0. So 2 numbers that multiply to 24, but if I add those same numbers, I get 11. That's pretty easy, 8 and 3. And again, watch the sign. It's a plus, meaning they're both going to be the same, and they're both going to be the same as whatever the first one is. So plus, plus. And again, and those are usually the easiest ones, are the plus plus ones. And in this case here, I'd have to x plus 8 equals 0, x plus 3 equals 0. And again, their 4 is still here, but I'm going to ignore that. Minus 8 from both sides, and then here I'd have to minus 3 from both sides. So now it looks like I'm going to end up with 2 negative numbers. And again, I want the one that is lower generally. So in this case, it'd be -8 and -3. Oops. And that's our solution set for this one. And here's our solution set for this one. -8 and -3. And we're on our last slide after this one. So that one, both of these were kind of easy. So I'm thinking maybe these next ones are going to be kind of hard. But we'll see. Okay, so let's go ahead and move on to the next one. And let's go ahead and look for the x square, which I only have one of them. So that makes it easy to pick which side it's going to go on. So that means I'm going to have to minus x and minus 21. 2x squared minus x minus 21. Okay, so we have an a value, and it looks like we can't do anything to get rid of it, because if I were going to get rid of it, this one would have to have an a value, which it doesn't. So we're going to have to go with option number 2 and just work with it. So to work with it, again, I'm going to just stick with one method. And even though it's not the best method for remembering things, it's the best method to make sure most students don't get stuck on this assignment if they're watching this video. 2 times -21 is -42. Now, don't let me forget that I'm supposed to divide by 2 after we get this factored, because I think I did forget that. So we have a negative sign. So a plus and a minus. Now I need 2 numbers that will multiply to 42, but if I subtract one from the other, I will get -1. Now these 2 numbers are going to be really close to each other, is what I'm guessing. So 40. Let's just I'm going to just make a factor list. Okay, so this would be 2 times 21, and then 3 times 14 is how I get 42. Let's see, 4 is not going to work. 5 is not going to work. 6 6 and 7. Okay, so yeah, 6 times 7 equals 42. That's going to be it because they have a 1 difference. Now, since I need a -1, this side is going to have to be slightly bigger. And again, check it at this step. Make sure you get 6 minus 1 is -1. I'm sorry, 6 minus 7 is -1. Set it equal to 0. And I think we're actually kind of done with this one here. But remember, I told you not to make me forget this. We borrowed, but now we must collect. So we gave a 2. Now it's time to get it back. So we times by 2, divide by 2, which makes this one pretty, well, okay, so let's see. 6 divided by 2 is 3. And just for fun, I'm going to go with decimal. Now I'm going to have to switch both of these up. X equals, now if I minus 3 from here, that's going to be my first solution is -3, and the second one is going to be, because I'm going to have to add 4.5 to both sides. I'm going to go with, now in this case, I'm going to go with half, because if I put 4.5, it's going to look like there's 2 commas. And there's only room for 1 comma here. So just 1 comma, otherwise again, it would look like there'd be 2 commas, or it might look like 3.4 and 5 or something like that. You know, because I know sometimes people don't draw them well enough to make it look like I know what it should be. All right, enough of that. Let's go ahead and go to the last one. This is the last one. So let's just get this moving, get it over with. Negative, oops. That means I'm gonna have to minus it from here. And I'm also gonna have to get rid of this 9. So I'm gonna have to add 9 to both sides here. I knew they'd be so close to each other, so I just used a different color here. So minus x and add 9 to both sides. So this side should 0 out. So there should not be anything left on that side. 4x squared minus 12x plus 9. Now in this case, it looks like we're ending up with another situation where we would have an a value, and I can't see any way to get rid of it because I could divide these 2 by 4, but I cannot divide 9 by 4, so that's not going to work out. So this means I'm going to have to make a new equation without an a value, and that means I'm going to have to multiply 4 times 9, which would be 36. Now I need 2 numbers that multiply to 36, but will add to -12. And if you have an idea, you could probably make it a little bit better. 2 times 18. 3 times 12, 4 times 9, 6 times 6. So in this case, oh, and this is why the sign is important, because I probably wouldn't have had to do this if I just knew what the signs I was looking for were. Remember, they're the same. That's what this plus means here. And if they are the same, they're both going to be the same as whatever this first one was. So I wouldn't have to bother making this list if I knew that they were both going to be the same. So just a bit of a heads up, you can save yourself a little bit of work. And it looks like we're going to have a second set where we only have one solution. But be careful, because again, we borrowed, now we must get it back. So we've multiplied by 4, we must divide by 4. And since they're both identical, well, we're only going to end up with one of them. So I'm going to have to add to both sides. Oh, I can also reduce it as well. So instead of 6 over 4, I'm going to add 3 over 2. Okay, so all I did was just reduce 6 over 4. So now it's 3 over 2. Now it's the same value. It looks different, which is one of the tricky things that fractions do. They can look different, but mean the same number, mean the same value. And again, if we're not sure, if you're completely not sure about this, well, you still have to show how you factored to get it. But we could also just move on to our graph. And I'm going to do that really quickly with our last one. So let's see, our first one was, I'm gonna graph it so that they're all the same. It's 4x squared. Oops, it's not square. 4x squared minus 11x, sorry, minus 12x plus 9. And if I were to zoom in, I should get 3/2, or the decimal equivalent of 3/2, right? If you had $3 and you had to split it 2 ways, it would be $1.50 each way, which in this case is 1.5. So we know we got it right. And again, you know, try to avoid, you know, just getting answers. Oopsie. I don't know if okay, so I did, I just punched it in here. So again, try not to get into the habit of getting answers. So I know there's that misconception that I talk about from time to time. So you've probably heard it before, but math class does not teach you math so you can go out into the real world and go do that math, okay? Because I can tell you there's a lot of people that have graduated and never used quadratic formula once in their life, okay? Most of these are not designed to be used as is. They're designed to get you thinking so that you learn patterns on how to think and, you know, solve new problems in an everyday situation, right? Because that's what math does, is that it better than anything else, it exercises your brain. If you go take a history class, it's all just about memorization. Well, more about memorization. There's some things you do have to think about, right? But in math, you always have to think about it, because unless you can memorize this exact problem, chances are very good you're gonna have to find a way to get the answer. So, I mean, you know, I really need to make like a video about that one of these days, but anyway, hopefully you get the idea. So that's why you got to show your work and not use tools to get your answer. Anyway, that's it for today. So it's definitely been a little bit of an over time. So I will see you next time. Bye-bye.